Hello guys, greetings of the day. Myself Pranit, and in this video we'll be discussing about JK and D flip-flops. Before going to start about JK and D flip-flops, first we'll discuss about circuits, different types of circuits. Those are combinational circuits and sequential circuits. Combinational circuits are the circuits in which the output depends only on the present input. Those are examples like encoders, decoders, multiplexers, adders. When it comes to combinational logic circuits, sequential circuits, the circuits in which the output depends on the both the present input as well as the previous output. Examples like latches, flip-flops. Okay, what do you mean by latches? Latches are the basic elements of for storing data or storing memory in a single bits, and it is a level sensitive. That means it changes its state based on the level of control signal usually referred as enable or clock signal or pulse. And when it comes to flip-flops, it is also same like as latches, and it is edge sensitive. This means flip-flop changes its state only at specific transition of clock signal or pulse. Those are different types of latches or SR latch, JK latch, D latch and T latch. And different types of flip-flops are same as latches: SR latch, SR flip-flop, D flip-flop, JK flip-flop and T flip-flop. Okay, for come to flip-flops. First is SR flip-flop. SR flip-flop is a flip-flop in which we'll be having two inputs and one output. Those two inputs are S and R, and this is the truth table for that. In this truth table, we'll be having four conditions for different values that we'll be providing for S and R. In first case, when we provide 0 and 0, the state is unchanged state. The output is unchanged, that is Q. When we provide S as 0 and R as 1, that time we'll get output as 0, that is reset condition. When we give S as 1 and R as 0, the output we'll be getting is 1, that is a set condition. Here the main problem arrives when S and R both given as 1 and 1, then it is invalid, because we'll get Q as 0 and Q dash also as well as 0. This is not true, because Q dash is complement of Q. When we get Q as 1, Q dash we should get as 0, and when we get Q as 0, we should get Q dash as 1. But here we are getting both as 0 and 0. This is not true. That's why to overcome this, we'll be using the second flip-flop, that is JK flip-flop. In this we'll be having two inputs, that is J and K. The outputs are Q dash and Q, and one more is CLK, that means clock signal, that it is always will put it as a 1, that is fixed. And when it comes to truth table, JK are inputs and Q of T, that means Q of T is the current state of flip-flop, and Q of T plus 1, it is the next state after the clock pulse. That truth table will get same as the SR flip-flop for the first three conditions. That is, when both given as 0, the output is Q and there is no change in the action. When J is 0 and K is 1, the output is Q and that is 0, that is the reset condition. When J is 1, K is 0, we will get output as 1, that is set condition. And there is the difference from SR flip-flop to J flip-flop, that is when both J and K given 1, we will get toggle condition. Okay, what do you mean by toggle condition? If the current state of Q is 0, when the toggle condition occurred, it will change it to 1. And when the current state is 1, when the toggle condition occurs, it will be changed to 0. And next, writing a Verilog program for JK flip-flop. And here is the first line is a module. We are defining the module name as JK, and the inputs we will be providing are JK and CLK, that means clock, and that will be high always. CLK is equals to 1, and EN is, that is enable signal, and output is Q, that is REG, means that is register Q, that will be storing the output Q either 0 or 1, and one more output is Q bar. The output stored in a Q is assigned to Q bar at the end. And here we'll begin the code. And first condition, if the enable signal is 1, that is always Q equals to, that is reset condition. Otherwise, if we don't give the enable signal, then the cases occur, that is case of JK. And here 0 0 means the first 0 refers to the J value and second value refers to the K value. As per the truth table, when both are 0 and the output remains unchanged, that is Q. When J is 0 and K is 1, that is reset condition, the output is 0. When J is 1 and K is 0, that is set condition, that is Q, output is 1. When both the inputs are high, that means 1 and 1, that is toggle condition, Q is equals to Q bar, that is complement of Q. And if the user provides the default input, that is some other input, and this is the condition, and we'll end the cases, and we'll assign the output stored in the Q to the Q bar in this manner, and we'll end this program. Next is D flip-flop. D flip-flop or data flip-flop. It is same as SR flip-flop or J flip-flop, but the input is only D. Only one input will be providing, and when it as per the JK flip-flop, there will be 4 conditions. One is unchanged condition, reset condition, set condition, and toggle condition. But in D flip-flop, we will be having only one input. Based on that, we will get only reset condition and set condition. This is the circuit diagram where Q is single input and Q and Q bar are outputs. This is EN or CLK, we can write in any ways, that is clock, that will be high always. This will be connected using NAND gates. When it come to truth table, D is 1. As we discussed, Q of T is the current state of the flip-flop and Q of T plus 1 is the next state after the clock pulse. The condition, when the first condition is D equals to 0, we'll get output as 0, that is reset condition, output also 0. When D is 1, the next state after the clock pulse output is 1, that is set condition. And we'll come to designing of Verilog program for D flip-flop, and here DFF, that means D flip-flop module name, and inputs are D, CLK, and then CLK means clock signal and EN means enable signal, as we discussed it before. And same register Q output, that will be storing the output, and Q bar will be assigning at the end. And same as the JK flip-flop, here we'll begin it, and if enable signal is 1, and it will be output will be reset, that is Q equals to 0. Else if the enable signal is not equals to 1, then according to the truth table, if we provide D is equals to 0, we'll get reset condition, that is 0. Otherwise, if we give D is equals to 1 input, the output will be 1, that is set condition. So when we are providing if we are providing 0, then output is 0. If we are providing 1, the output is 1. So we will be assigning this way and we have stored the output in K, that is assigned to Q bar. And this is the end of the module. This is the explanation about JK and D flip-flops. I think you have understood. Thank you.